This is page 261. This is use substitution continued. And this is the pattern recognition version. Okay. All right. So looking at example 2a, we need the derivative of x squared plus 1. It's 2x. The derivative of x squared plus 1 is 2x. But we only have x here. So it's missing a 2. It's missing just a number. When it's just missing a number, you can put a number in there, but you have to compensate for what you put in, and I'm going to put a half there, right? So 1/2 times 2 is 1. I put one number on the inside and one number on the outside of the integral, okay? The number on the inside is needed for the completion of the pattern, and the 1/2 compensates for the fact that I put a number in, right? So I haven't changed the problem. 1/2 times 2 is 1, so I haven't changed it. Okay, so then it's 1/2 x squared plus 1 to the 7th over 7 plus c. So it's 1/14 x squared plus 1 to the 7th plus c. That's example A. Example B, here, I'm looking for the derivative of 2x plus 1. The derivative of 2x plus 1 is 2. So I am allowed to put a 2 in, but have to compensate for that 2 by putting a half outside. Right, so that's the same thing as 1/2 integral of 2 times 2x plus 1 to the 1/2 dx. All right, so that means I can integrate that. There's the pattern. The derivative of 2x plus 1 is 2. So I'm just going to do 1/2. So this 1/2 is that 1/2. And I'm going to do 2x plus 1 to the 3/2 divided by 3/2 plus c. And then multiply that. That's going to be 1/2 times 2/3 times 2x plus 1. And I'm running out of space. 3/2 plus c. The 2's cancel. So it's 1/3 2x plus 1 to the 3/2 plus c. That's a 1. All right. That's the answer there to B. Example C. I'm looking for the derivative of x to the 5th minus 8. And so this one can't be done. Okay, omitting that one. All right, look at the next one. I'm looking for the derivative of 4x cubed minus 1. That's going to be 12x squared. So I'm missing a 12. So compensate for that 12 with a 1/12. So I'm going to rewrite that as 1/12 12x squared to the 4 of the 4x cubed, minus 11 to the 1/3 power dx. So it's 1/12. Integrate that. That's going to be 4x cubed minus 11. Add 1. That's 4/3. Multiply by the reciprocal. So it's 3/4. So that's going to be 1/16. 4x cubed minus 11 to the 4/3 plus c. Right? 3 and 12 reduce. 2 4s. 4 times 4 is 16. C. All right. So remember last time we saw something like this. The derivative of tangent x is secant squared. So I have an extra 2 here. So I'm just going to rewrite it with the 2 on the outside and go back to what I had. So that becomes the derivative of tangent x is secant squared x. So that's going to be 2 times tangent x minus 1 to the 2nd power divided by 2 plus a constant. So the 2's reduce. It's just tangent x minus 1 to the 2nd plus c. Wow, that's awful handwriting. It's Saturday morning. What do you expect? All right. 7 sine 3x. So what's the derivative of 3x? The derivative of 3x is 3. That's not a 3. So what I'm going to do is rewrite this. Put the 7 on the outside. Put the 3 that I need. But when I put the 3 that I need, I have to compensate for that 3 by dividing by 3. All right. So now I have the pattern. So that becomes 7/3. The integral of sine is negative cosine. So it's negative cosine 3x plus c. That's it. G. what is the derivative of 2x cubed? It's 6x squared. So this has a 3. I am missing a factor of 2. So if I multiply the 3 by 2, and then compensate for that 2 by putting a half out there, I could do 1/2 6x squared, 2x cubed plus 5 dx. Now use the power rule on that. So it's 1/2 2x cubed plus 5 to the second power over 2 plus c. So it's 1/4 2x cubed plus 5 to the second plus c. All right, just occurred to me. You could have just multiplied that out, multiply this out, and not do this use substitution stuff. Because that's an exponent of 1, so you can just multiply it out. But I'm going to leave it like that. H secant 2x tangent 2x, that is the derivative of secant x. Well, except for the 2. So I need the derivative of 2x, which is 2. Compensate for that 2 by putting a half out there. So I'm going to rewrite this so you can see it. I realized I probably should have done that for earlier problems, but I didn't. So that is the derivative of secant 2x. So it's 1/2 secant 2x plus c. And then I cosine 2x. I need the derivative of 2x, so I need a 2 there. Compensate for that 2 with a half. All right, so that's 1/2 derivative of cosine, or integral of cosine sine, so it's sine 2x plus c. If you have doubts, like, when you first encounter a new topic, you don't see why it is what it is, go ahead. This is an easy one to help assuage those doubts. What's the derivative of half sine 2x? Well, if this were y and I take the derivative of that, so you would do 1/2 derivative of sine is cosine 2x. Continue with chain rule. You're going to multiply by the derivative of 2x, which is 2. When you take the derivative of constant, it's 0. This 2 and a half cancel each other, and you get cosine 2x. That's the original problem, right? That's what's supposed to happen when you integrate this. Right? When you integrate this and you take the derivative, you should get the original function back. All right, J. Cosecant squared. That's the derivative of cotan x, except it's missing a negative, and there's a 6 there, right? So it's missing a 1/6. It's missing a 1/6. So I need a negative 1/6 cosecant squared theta over 6 d theta. So to compensate for that negative 1/6 I threw in, I'm going to put a negative 6 on the outside, right? Negative 6 times negative 1/6 is 1. All right, so then it comes negative 6. The integral of negative 1/6 cosecant squared x is cotan x, well, cotan theta over 6 plus c, and that's the answer. Here we got 5 e to the 5t. We need a derivative of 5t. That's a 4. So I'm going to rewrite it this way. I'm going to take the 4 outside, put a 5 inside, compensate for that 5 by dividing by 5. So that means I have 4/5 e to the 5t plus c. Because now I have the pattern here, so I just integrate that. Integral of 5e 5t is e to the 5t. All right. Compensated for the 5 I stuck in by putting the 5 in the denominator here, and that 4/5 sticks around to the end. All right, L, I'm going to do some rewrites here. I'm going to rewrite this as sine 3x to the second power. A lot of people get confused by the way the trig function is written with exponents, but these two are equivalent, okay? So that means I have a lot of functions here. 3x is inside of sine, and sine 3x is inside of the exponent of 2. What is the derivative of sine 3x? The derivative of sine 3x is 3 cosine 3x. So this is missing a 3. So I am going to put a 1/3 outside because I'm going to put a 3 in there. Sine 3x squared. That's going to be 3 cosine 3x, which is the derivative of sine 3x. All right. So that's 1/3. Now that's the pattern. So I can use sine 3x to the third power over 3 plus a constant, right? I'm not using the power rule on that exponent of 2. So that becomes 1/9 sine 3x to the third plus c. That's a 3. Sorry, not a 33. I'm going to write it in the normal way. Sine cube 3x plus c. All right, that's it. Moving on to m. Oh, joy. All right. So this one's actually easier if you did use substitution. But this is pattern recognition video. So I will do pattern recognition. So here, I'm going to rewrite this so it's easier to see the pattern. E to the 1 over x times, so this over x squared is the same as 1 over x squared dx. All right, so 1 over x, the derivative of 1 over x is negative 1 over x squared. So pattern recognition only works if you're really good at taking derivatives. And I have a feeling many of you would not be able to spot this one. The derivative of 1 over x is negative 1 over x squared, so it's missing a negative. I'm going to compensate for the negative. I put a negative out there. So when I integrate that, it's negative e to the 1 over x plus c. Okay, that's pattern recognition. If you don't recognize that pattern, I suggest you watch the other video. All right, and here, this is, I'm going to rewrite this first. That's 3t minus 5 to the 1/2 dt. So I need the derivative of the inside. The derivative inside is 3. I put a 3 there, compensate for that 3 by putting a 1/3. So that's going to be 1/3 3t minus 5 to the 3/2 divided by 3/2. And I'm bringing in a space. So put it here. All right, so I'm going to flip that up. So it's 1/3 times 2/3, right? Whenever you have a fraction in the denominator, flip it, put it up there. 3t minus 5 to the 3/2 plus c. So that becomes 2/9. 3t minus 5 to the 3/2 plus c. And that's my answer. That's the final example on page 261. All right, page 261, example L, and we're done. Bye-bye.